Question number 6. The sun emits a continuous spectrum of electromagnetic waves, means EM waves. Figure number 14 names some of the groups of the waves in the electromagnetic spectrum. We can see here we have infrared radiation, visible light, ultraviolet radiations, and gamma rays. (6.1) is an AO1 question. Name the group A, B, and C in figure number 14. We know that in electromagnetic spectrum, we have the radio waves, microwaves, infrared radiation, ultraviolet radiation, we have gamma radiation, we have X-rays, and we have visible light. Out of the 7 of electromagnetic radiations, we have only 4: infrared, visible light, ultraviolet, and gamma rays. The electromagnetic spectrum, it starts from radio waves and ends at gamma rays. So the A is radio waves, B is microwaves, C is X-rays. Let's see the model answer. So A is radio waves. In our spectrum, B is microwaves and C is X-rays. It is an AO1 question. The student must know the names of the waves in the electromagnetic spectrum. 6.2 is an AO1 question, and this question is again from the topic of electromagnetic waves. Give one similarity and one difference between the properties of ultraviolet waves and gamma rays. If we look into ultraviolet waves and gamma rays, we can see both the rays are from the EM spectrum. As both of them are from the EM spectrum, so they have same speed. Both can travel through the vacuum and both can transfer the energy from one place to another place. And both of the waves in the electromagnetic spectrum are transverse waves. But on the other hand, the ultraviolet radiation is less ionizing as compared to gamma rays. We can see here the frequency of the wave of the ultraviolet radiation is less as compared to gamma rays. Gamma rays are more penetrating due to having high energy as compared to ultraviolet radiations. Let's see the model answer. The different options are given in similarities and differences for the students. The similarity between ultraviolet waves and gamma rays is both have the same speed, that is 3 into 10 raised power 8 meter per second. Both can travel through the vacuum and both are transverse waves. The student can pick one of the difference. Gamma rays have high frequency than ultraviolet waves. Gamma rays are more ionizing than ultraviolet waves. Gamma rays are more penetrating than ultraviolet waves because of having high energy. Gamma rays have shorter wavelength than the ultraviolet waves. We can see here the size of the wave is shorter as compared to the size of the wave in ultraviolet radiation. Figure number 15 shows a white light split into the spectrum of different colors by a glass prism. You can see here a white light is entering into the prism and it splits up into different colors. 6.3 is an AO1 question, and this question is from the properties of EM waves. Light changes direction when it enters the glass prism. What name is given to this process? We know that as the light is entering from one medium to another medium, it changes the direction. And the change of direction is called refraction. A student must know the definition of refraction so that they are able to give the answer of 6.3. It enters from the air into the glass prism or from one medium to another medium. Therefore, the ray of light is changing the direction and splits up into different colors. So the name of the process is refraction. Student can use the equation sheet to answer 6.4 and 6.5. 6.4 is an A1 question, and this question is from the topic of properties of waves. Write down the equation that links frequency, wavelength, and the wave speed. From the equation sheet, we can see that the speed of the wave is equal to frequency times wavelength. So V is equal to F into lambda. 6.5 is an AO2 question. The student need to make the calculation in this question. The wave in the middle of the spectrum has a wavelength of 5 times 10 raised power minus 7 meter. The wavelength is given. The wave speed of the light, that is 3 into 10 raised power 8 meter per second. Calculate the frequency of the wave. In 6.5, we know that V is equal to F times lambda. The wavelength is given, the speed is given, we need to find the frequency. We will use both the values in the above equation and we can find the frequency of the wave. Let's see the model answer. From 6.4, we know that V is equal to F times lambda. Wavelength and speed are already given. So we will use these values in our equation. So the speed is 3 10 raised power 8 meter per second, and the frequency we need to find, whereas the wavelength is given 5 times 10 raised power minus 7 meter. By rearranging the equation, the frequency is 6 into 10 raised power 14 Hertz. Frequency of the wave 6 into 10 raised power 14 Hertz. The marks distribution is given along each required step. Question number 7. A student investigated how the acceleration of a trolley is affected by the force acting on the trolley. Figure number 16 shows some of the equipment used in the experiment or in the investigation. If we look into the question 7.1, describe a method the student could use. Your answer should include any extra equipment needed. This question is from the topic of Newton's second law, and it is an AO3 question. We need to use the figure and we'll see that what the extra equipment a student needs to use in the investigation. We can see there the trolley is at the ramp, and the student will use the string and tie the string to the trolley and pass the string over the pulley at the edge of the desk or the table. On the other side of the string, the student will hang the weight holder and adds the weight and see that impact of the force acting on the trolley. The student can put the start mark of the trolley so that he can find the distance between 2 points to find the acceleration of the trolley. Or the student can use the light gates to find the acceleration of the trolley, and with the help of the computer or the data logger, the student can find the acceleration of the trolley. The student can add the weight and see the impact of the force on the trolley. As the weight is increasing, it means the downward force is increasing. It will apply more force on the trolley. As the result of that, the acceleration of the trolley will increase. Let's see the model answer. Number 1. Clamp a pulley onto the edge of the desk as shown in the figure number 16. Use the light gates to find the acceleration of the trolley with the help of the data logger. Or the student can use the stopwatch to find the distance traveled and use the formula V is equal to S over T, and acceleration is equal to delta V over T to find the acceleration of the trolley. Attach a string with the trolley and passing over the pulley and is connected with the mass or the weight holder to see the effect of the force on the acceleration of the trolley. Mark the starting point of the trolley on the runway to measure the distance traveled by the pulley during the experiment. Add mass to the weight holder and find the force W is equal to mg on the trolley to move it on the runway. The student will repeat the experiment for different masses of the forces and observe the effect of the acceleration due to the change of masses. Table number 2 shows some relation between the force and the acceleration. The force is 1.2 Newton, the acceleration is 1.6 meter per second square. 7.2 is an AO1 question, and this question is from the topic of Newton's second law. Which of Newton's law predict that the acceleration of the trolley is proportional to the resultant force? We know that Newton's second law says the force is directly proportional to the acceleration. As the force is increasing, the acceleration produced in the trolley will increase. So it is Newton's second law which relates the force and the acceleration. Seven point three is an AO3 question, and this question is from the Newton's second law of motion. Determine the acceleration of the trolley when the resultant force is 3.6 Newton. Use the table number 6. We will explain this question by two different methods. We need to use the table number 2 and we need to calculate the acceleration produced due to the force of 3.6 Newton. In table number 2, we can see here if the force is 1.2 Newton, the acceleration produced is 1.6 meter per second square. But we don't know what is the acceleration when the force is 3.6 Newton. There are two methods. When the force is 1.2 newtons, the acceleration produced is 1.6 meter per second square. And when the force is 3.6 Newton, we don't know the acceleration. So we are using ratio and proportion method to find the acceleration. To make x and a subject by ratio and proportion method, the x is equal to 1.6 times 3.6 and 1.2 will divide it. The answer is 4.8 meter per second square. We will use table number 2 for our second method. We know that in table number 2, the force is 1.2 and acceleration is 1.6. We will use Newton's second law, F is equal to ma, to find the mass of the trolley. The mass of the trolley is F over a. We will divide the force by the acceleration to find the mass of the trolley. The mass of the trolley is 0.75 kilogram. We know that the force is 3.6 Newton and the mass is 0.75 kilogram. We will use the formula F is equal to ma to find the acceleration produced by a force of 3.6 Newton. Let's see the model answer. We already calculated our mass, that is 0.75 kilogram of the trolley. We will use the formula F is equal to ma. The force is 3.6 Newton. The mass is 0.75 kilograms. We need to find the acceleration a. We will make a as a subject. Therefore, 0.75 will divide 3.6. With the help of the calculator, the answer is 4.8 meter per second square. Student can use any of the method, whether by ratio proportion method or by calculating the mass first and using the Newton's second law. 7.4 is an AO1 question. The student can use the equation sheet to answer 7.4. Write down the equation that links acceleration, mass, and the resultant force. So we know that the force is equal to mass into acceleration of the object, which is actually the Newton's second law. So the resultant force is mass into acceleration. 7.5 is an AO2 question, and this question is from the topic of Newton's second law. The force is given 0.42 Newton and the acceleration is 1.2 meter per second square. The student need to calculate the mass. We will use the equation force is equal to mass into acceleration. The force is already given. Acceleration is 1.2 meter per second square and we need to find the mass of the trolley. Let's see the model answer. We know that force is equal to mass into acceleration. The force is 0.42 Newton. The mass we need to find and acceleration is 1.2 meter per second square. To make mass of the trolley as a subject, 1.2 will go on the other side and it will divide 0.42. So the mass of the object is, or the mass of the trolley is, by using the calculator, that is 0.35 kilograms. Question number 3. Our teacher used a ripple tank to demonstrate water waves. The teacher used a lamp to project a shadow of water waves on a screen below the ripple tank. 3.1 is an AO2 question and it is from the required practical activity number 20, and this topic is from properties of the wave. If we see the figure number 4, which shows the shadow of the water wave on the screen below the ripple tank, we can see the total distance that is from this wave to this wave that is we have measured with the help of the ruler, and that is approximately 113 millimeter. The scale is given that 1 millimeter on this paper, that is actually 5 millimeter on the screen below the ripple tank. The student need to find the distance between the waves. The question is, determine an accurate value of the wavelength of the wave on the screen. The definition of the wavelength is the distance between two consecutive crests, or the length of one complete wave. That is called a wavelength. From here, we need to use the figure number 4. The student need to use a ruler, and with the help of the ruler, the student need to find the distance between the crest of the first wave to the last wave. I use the ruler, and with the help of the ruler, this distance is approximately 113 millimeter. And the student need to find the wavelength, and the easiest way is to find the wavelength between 2 points is the distance traveled between two crests. With the help of the crest, we can find how many waves are there. 1, 2, 3, 4, 5, 6, 7, and 8. The total distance traveled is 113 millimeter, and the number of waves is, that is 8. So lambda, or the wavelength, is equal to total distance traveled by waves over number of waves. So the total distance traveled is 113 millimeter and number of waves is 8. So we will divide 113 by 8 and we will get the size of one wave. If we see the working, so distance of the waves, that is equal to 130 millimeter, which the student will find with the help of the ruler in the real exam. So number of the waves, that is equal to 8, which we already counted. So size of one wave, or lambda, that is equal to 113 our number of the waves, that is 8, and with the help of the calculator we will find it is 14.125 millimeter on the exam paper. The scale is already given, the 1 millimeter, that is equal to 5 millimeter. Therefore, we will multiply this value 14.125 with 5, and the answer is 70.625 or 70.63 millimeter on the screen below the ripple tank. The teacher adjusted the frequency of the waves produced in the ripple tank. The teacher measured the wavelength of 5 waves. The table number 2 shows the results. You can see the number of the wavelengths 1, 2, 3, 4, and 5. And the wavelengths in millimeter, that is given here, 96, 99, 97. The unknown value is x, 97, and the mean value is 97. 3.2 is an AO2 question, and this question is from property of the waves. Calculate the value of x in the table. So we need to find the value of x. So we know that the mean is sum of all the waves divided by number of waves. If we see here, the mean value is sum of all wavelengths. We have 1, 2, 3, 4, and 5 wavelengths, and number of waves are 5. So we will divide 96 plus 99 plus 97 plus x plus 97 or 5 is equal to the mean value, and the mean value is already given, that is 97. We need to rearrange the values. So this 5 will go on the other side and will times 97, and we will get 97 into 5, that is equal to 389 plus x. If we add these values with the help of the calculator, we will get the answer 389. So when this 389 is going to other side, we will make x as the subject. So the value of x is 96 millimeter with the help of calculator. AO3 question. The teacher states that the results are very precise. Which of the following supports the statement made by the teacher? Students make a common mistake. They are unable to differentiate between the word precise and accurate. Precise means how consistent the measurements are, or what is the spread of the values. If the spread of the values are very close to each other, we will say that the values are very consistent. It means the results are very precise. Whereas the accurate means how close the measurement is to the true or the accepted value. The spread of the value above the mean is very small, means the values are very consistent and the spread of the value is very small. So the correct option is number 2. 3.4 is from the topic of longitudinal waves and the transverse waves. Describe the difference between the longitudinal waves and the transverse waves. We can see in the diagram the movement of the particle is perpendicular to the motion of the wave. We can see the wave pattern is generating, which is going in forward direction, whereas the movement of the particles of the medium, that is up and down. So the oscillation of the particles or the movement of the particle is perpendicular to the direction of the wave. The wave pattern is going in the right direction, whereas the movement of the particle is in the upward and the downward direction. Therefore, we can see here the particle movement is perpendicular to the direction of the wave. In this figure, we can see here the movement of the particle is towards the wall. As the result, the wave pattern is generated. The motion of that wave pattern is also towards the wall. So we can say here that the oscillation of the particles is in the direction of the energy transfer or in the direction of the wave pattern. So the particles and the wave pattern both are in the same direction. Let's see the model answer. In transverse wave, the oscillation of the particle is perpendicular to the direction of energy transfer, such as EM waves. Whereas in longitudinal waves, the oscillation of the particles or the movement of the particles is parallel to the direction of the energy transfer. So energy transfer or the energy pattern is towards right, towards wall, whereas the movement of the particles of the spring is also towards the wall, such as the sound waves. Question number 4. A teacher demonstrated the motor effect. Figure number 5 shows the equipment used. The equipment includes a permanent magnet. We can see here a permanent magnet is given here. A rod is present. And the brass rail is present here for the movement of the copper rod. This is the electric circuit. In the electric circuit, we can see here the power supply, the ammeter, variable resistor, and a switch. 4.1 is an AO1 question. The copper rod remains stationary while the switch is open. Complete the sentence. The tendency of an object to remain stationary is called inertia. This is the definition of inertia, and this is from the Newton's first law. So Newton's first laws describe inertia is the property of an object to resist any change in its state of rest or motion. It means if something is stationary, it wants to remain stationary at its position, or something is moving with a uniform speed, it wants to remain in the position of the uniform motion forever. The tendency to object that any change in its state of rest or the motion, that is called inertia. When the switch is closed, the copper rod accelerates. 4.2 is an AO2 question, and this question is from the topic of Fleming left-hand rule. In which direction will the copper rod accelerate? We have four different options. Before giving the answer, the student must have a good information about Fleming left-hand rule. According to Fleming left-hand rule, if we stretch the index finger, the middle finger, and the thumb of the left hand at an angle of 90 degrees with each other, the direction of the index finger shows the magnetic field. whereas the middle finger shows the direction of the current and the thumb gives the direction of the force in which direction the rod will move. We are using figure number 5. We can see here when the current is flowing, the direction of the current is given here, whereas the direction of the magnetic field is from the north pole to the south pole. When we're using the Fleming left-hand rule, we can find the direction of the force on the rod according to the Fleming left-hand rule is towards right side. So when the switch is closed, the direction of the force on the rod is towards right side. The correct option is towards right side. 4.3 is an AO1 question, and this question is again from the Fleming left-hand rule. Explain one way the teacher could increase the acceleration of the copper rod. Mean how the teacher can increase the acceleration or the speed of the copper rod towards right. It is only possible if there is more force on the rod and the rod can move towards the right side with the greatest speed. The teacher can increase the current within the circuit or using more powerful magnet. So as the result of that interaction between the current and the magnetic field produced by the magnet, it will generate more force on the copper rod. Let's see the model answer. If the current is increased in the circuit or in the rod, it will increase more force on the copper rod. As a result, it will start moving with a greater force. Or student can write the answer, use a stronger magnet because it has a strong magnetic field and can interact more with the magnetic field produces around the rod. So it will increase the resultant force on the rod. As a result, it produces more acceleration in the rod towards the right side. 4.4 is an AO3 question, and this question is from the topic of poles of a magnet. The magnet used in the demonstration was a permanent magnet. Figure number 6 shows an iron bar and a permanent magnet. Describe how the permanent magnet could be used to test if the iron bar is also a permanent magnet. In figure number 6, we can see here we have a permanent magnet, but an iron bar is given. We don't know anything about if the iron bar is also a permanent magnet or not. We need to bring this iron bar closer to the permanent magnet. If there is attraction and repulsion between the iron bar and the magnet on changing the poles of the iron bar, so it shows that iron bar is also permanent magnet. But if the iron bar is attracted towards the permanent magnet, even changing the poles towards the permanent magnet, so it is just an iron bar because iron is a magnetic material. Let's see the model answer. Bring the iron bar closer to the permanent magnet, and there is repulsion on changing the poles of the permanent magnet, then the iron bar is a permanent magnet. Either we can change the poles of the permanent magnet or we can change the direction of the iron bar towards the permanent magnet. If there is attraction and repulsion between them, then iron bar is also permanent magnet. If the iron bar feels the force of attraction only, even on changing the poles of the permanent magnet, if we change the poles of the permanent magnet, the iron bar only attracts the force of attraction, then the iron bar is not a permanent magnet. 4.5 is an AO1 question, which is a knowledge based question. Figure number 7 shows a magnetic compass used by walkers. We can see here a magnetic compass. We can see the north pole directed by the magnetic compass. Explain how a magnetic compass provides evidence that Earth has a magnetic field. We know that Earth has a magnetic field around it. We know that the Earth geographical north pole is actually the south pole, and geographical south pole is acting as the magnetic north pole. Therefore, this compass will try to align itself with the Earth's magnetic field. Let's see the model answer. The compass needle always points towards one direction, mean the north pole of the earth, because the tip of the needle is also magnetic. The needle will align itself with the earth magnetic field because there is a magnetic field around the earth. It looks that earth has a big magnet in the center. Question number 5. Figure number 8 shows a garden chair hanging from a spring. This question is from the topic of forces and elasticity. We can see here a man is sitting on the chair. As a result of that, the weight is acting downward. As a result of this, there is an extension in the spring, which is represented by small e. 5.1 is an AO1 question. Which of the following describes the relationship between the weight W acting on the spring and the extension E of the spring? Tick one box. We have different options. Weight is equal to E. Weight is directly proportional to E. Weight is approximately equal to E, or weight is less than E. We know that within the elastic limit, force and weight are directly proportional to each other. As the weight is increasing, the extension in the spring will also increase. Therefore, we will say that weight and extension are proportional to each other. So the correct option is weight is proportional to E. 5.2 is an AO2 question, and this question is again from the topic of force and extension. The person in the figure number 8 has a weight of 750 Newton. The extension happens in the spring, that is 16 millimeter. We need to convert the units from millimeters to meters. Calculate the spring constant of the spring. So we know that the weight is given 750 Newton. Extension in the spring happens, that is 60 millimeter. We know that 1 meter is equal to 1000 millimeter. Therefore, we need to divide 60 by 1000 to get the answer in meters, and that is equal to 0.06 meters. We need to calculate the spring constant, which is K. We have the formula force is equal to KE. We need to put the values of the force and the extension, force and the extension, to find the value of K by rearranging the formula. Let's see the model answer. After substituting the values, the force is 750, the value of K is unknown, whereas the extension in the spring is 0.06. When 0.06 will go another side, it will divide. We will get the value of K with the help of the calculator, that is 12,500 Newton per meter. The manufacturer of the chair tests a new spring to see if it is suitable to hang the chair. The spring can store a maximum of 1800 joules of elastic potential energy before it becomes inelastic deformed. 5.3 is an AO1 question. Describe what is meant by inelastically deformed. Inelastically deformed means that the body or the spring or an object will not recover its shape even the force is removed from it. Let's see the model answer. An object undergoing inelastic deformation will not return to its original shape or length even the force applied on it is removed. It means there is change in the shape or there is change in the length of the object on applying the force. 5.4 is an AO2 question, and this question is again from the topic of forces and extension. Calculate the maximum extension of the spring before the spring becomes inelastically deformed. Spring constant value is given. We have the value of elastic energy, that is 1800 joules. Spring constant value is 225 Newton per meter. We need to find the spring extension. The formula for elastic energy is EE is equal to half KE square. We need to put the values of the energy and the value of K to find the value of E. Let's see the model answer. We have energy. We will substitute the value of energy here, the value of K in our formula. We can see here the E square is equal to 1800 over 0.5 times 225. Therefore, we need to take the square root on both sides. With the help of the calculator, we can find the value of E is 4 meter. The mark distribution is also given along with the steps. 5.5 is an AO3 question. Evaluate the suitability of the new spring to hang the chair. We know that the person is sitting on the chair. As a result of the weight of the person, the chair is going down and the extension happens in the spring. The maximum elastic potential energy is 1800 joules. The spring constant value is 225 Newton per meter. The weight of the person is 750 newtons and the distance between the bottom of the chair and the ground is 30 centimeters. We need to evaluate if the new spring which is used is suitable for this chair or not. The manufacturer needs to calculate the extension in the spring and compare with the value of the extension with this value, and if it is less than 30 centimeters, then the new spring is suitable for making the chair. Let's see the model answer. We know that force is equal to Ke. The man has a weight of 750 Newton. Spring constant value is given in the formula 225 and the value of E is calculated. With the help of the calculator, we can find that when a person has a weight of 750 newtons and spring constant value is 225, the extension will happen, that is 3.33 meters. Whereas the distance between the chair and the ground is just 30 centimeters. Whereas when this person of 750 newton sits on the chair, the extension happens and this chair will start touching the ground. It means that the spring used for this weight of 750 Newton or for this chair is not suitable. Question number 6. Figure number 9 shows a child dropping a stone into the water. We can see here the child is holding a stone and it is dropping the stone into the water. The child drops the stone as it passes the child's feet with a velocity of 3.1 meter per second. The child is dropping the stone from the hand. When it is passing through the feet, the speed is 3.1 meter per second. So we will take it the initial speed of the stone as 3.1 meter per second. The child's feet are 6.3 meter above the water. So this distance is 6.3 meter. The acceleration due to gravity is 9.8 meter per second square. The value of g is 9.8 meter per second square. Calculate the velocity of the stone as it hits the water. We need to find the velocity of the stone as it hits the water. Use the physics equation sheet and your answer must be up to two significant figures. We can see here the distance traveled, that is 6.3 meter. The value of g is 9.8 meter per second square. The initial velocity we will consider as the stone is passing from the feet of the girl. We need to find the velocity of the stone on hitting the surface. We will consider as the final velocity. We will use the Suvat equation. V square minus U square is equal to 2gs. Let's see the model answer. We need to substitute all the values. The distance is given, value of g is given, whereas initial velocity is also given. We need to substitute all the values in our equation. V square minus U square is equal to 2gs. V square minus 3.1 square, which is actually the initial velocity, that is equal to 2 value of g 9.8 meter per second square into the distance traveled by the stone, that is equal to 6.3 meter. With the help of the calculator, we can see here the v square, that is equal to 133.09. We need to take the square root on both sides. We will get the value of v, that is 11.53646 meter per second. The demand of the question is up to two significant figures. So first two significant figures are 1, 1. Therefore, we need to round up our values because this value is 5, which is greater than 4. Therefore, the value of V will become 12 meter per second. 6.2 is a question from the topic of acceleration and scalar and vectors topic. Velocity is a vector. Describe the velocity of a stone as it falls through the air. Assume there is no air. We will see as the stone is falling down, and if there is no air resistance, means there is no drag, it means that it will keep going in the same direction and there is keep increase in the speed of the stone. Or we will say that the velocity or the speed of the stone will keep increasing uniformly because there is no drag force acting on the stone. Let's see the model answer. As there is no drag force on the stone, which is given in the question that there is no air resistance, therefore the direction of the stone is not changed. Therefore, the stone is keep moving downward. The velocity of the stone will keep increasing uniformly because there is no opposing force acting on it. 6.3 is again from the topic of acceleration. Figure number 10 shows the stone just after it has entered the water. We can see here when the stone will enter into the water, due to its weight, it is going downward. The direction of the weight or the direction of the velocity is downward, but the drag force due to the water is in the opposite direction to the motion of the stone or the pebble. As the stone wants to go downward, the drag is in the opposite direction and it will try to push it upward. The resultant force is drag force minus weight. We will find the resultant force acting on the stone. As the stone is going downward, the drag force will keep increasing until the drag force and the weight of the stone will become equal. Therefore, the stone will start moving with a uniform speed in the downward direction. As the stone moves through the water, the stone slows to a constant velocity. Explain why. Let's see the model answer. As the stone enters the water, it faces the drag, which is opposite force from the water. We know that this stone is coming downward, but the drag is applied by the water on the stone. This drag force is opposite to the direction of the velocity or the weight because weight is also acting downward. This drag is opposite to the direction of the weight or the velocity. The drag is greater than the weight of the object, therefore, the stone will slow down due to the resultant force. We know that this drag is more than the weight. The resultant force is actually in the upward direction. As a result, the stone will get slow when it enters into the water. When the drag upward means the upward force and the weight, which is actually downward force, they become equal, the stone will start moving with a constant or uniform velocity in the downward direction. The student needs to mention these 4 points to get 4 marks in this question. Question number 7. A car contains a device called a black box. The black box records the velocity and the acceleration of the car. The car was traveling with a constant velocity. The driver then reacted to a hazard. Figure number 11 shows the velocity time graph of the car. In figure number 11, we can see the graph is showing the velocity time graph. The velocity is along y-axis, whereas the time is given along x-axis. According to the given information, the driver is driving the car with a uniform velocity at a speed of 26 meters per second. At the time of 2 seconds of the journey, we can see here the graph is going down, which shows that the speed or the velocity of the car is changing and it becomes zero after 5.25 seconds. Determine the deceleration of the car, give the unit. Deceleration means the decrease in velocity. We can see here at 2 seconds, the velocity of the car is decreasing from 26 meters per second to 0 meter per second. It is a velocity time graph, so therefore the change in velocity with respect to time, that is called acceleration. Let's see the model answer. By using the graph, we know that the change in velocity with respect to time, that is called acceleration. The velocity of the car at 2 meters per second is, that is 26, whereas the velocity of the car after 5.25 seconds, that is 0 meter per second. The change in velocity is, if we take this value as the second value and this value as the first value, therefore the acceleration is y2 minus y1, that is 0 minus 26 over x2 minus x1, 5.25 minus 2. We can get the answer, that is minus 8 meter per second square. The student can ignore the negative sign. Negative sign shows the negative acceleration, means deceleration. So deceleration is 8 meter per second square. 7.2 is a combination of AO2 and AO3 question. The driver of the car has a reaction time of 0.75 second. So the reaction time is also given here. Determine the stopping distance of the car. Use the equation sheet. Also, we need to use the figure number 11. We know that the stopping distance is equal to thinking distance plus the braking distance. We will use the same graph, and the reaction time is given here 0.75 seconds. 0.75 is the time when the driver is going to see the hazard and react according to the hazard. From the graph, we can see here at 2 seconds, the driver will start applying the brake and the car will get stopped at 5.25 seconds. The reaction time is the time before applying the brake, and that is given 0.75 seconds. So the driver is applying the brake at 2 seconds. Before 0.75 seconds, the driver is going to observe the hazard and aiming to get stopped by applying the brake. The distance traveled by that time, 0.75, that is the thinking distance, whereas the distance traveled after applying the brake, that is called the braking distance. If you look into the figure number 11, the distance traveled when the driver is thinking to apply the brake, that is called thinking distance, and it is like a rectangle. Whereas the area under the graph of the braking distance, that is called the braking distance. Therefore, we need to find the total area under the graph in this region to find the stopping distance. Let's see the model answer. The thinking distance from the figure, we know that that is equal to velocity times time. The velocity of the car during the thinking distance, that is 26 meter per second. The reaction time is already mentioned in the question, that is 0.75. If we time 26 times 0.75, the answer is 19.5 meter. Therefore, the distance traveled by the car in a time of 0.5 second is 19.5 meter. Whereas the braking distance is the distance traveled when the driver will start applying the brake and the car will get stopped. We can see from the graph it is actually the area of a triangle. The area of the right angle triangle, we can see that is half base into the height. The height is 26, where the base is from 2 to 5.25, that is actually 3.25. When we multiply all the values or substituting the values in the equation, by substituting the values in the equation, we can get the answer. The braking distance is 42.25 meters. Whereas the stopping distance is sum of the braking distance and the thinking distance. If we add them together, we will get the answer, that is 61.75 meter. 7.3 is an EO1 question, and this question is from the topic of factors affecting the braking distance. If the black box records large decelerations, it identifies that the driving may be dangerous. It identifies that the driving may be dangerous. Explain why the large decelerations may be dangerous. If you use figure number 11, we can see here, if you apply a sudden brake, the change in velocity is going to be very sharp. The graph will become very steeper and it becomes dangerous for the driver. Due to the large deceleration, the brakes of the car will become overheated and the driver will unable to control the car. Let's see the model answer. Due to large deceleration, the brakes of the car will be overheated and the brakes will stop working properly. The other option the student can write in the answer, the driver may lose the control because the tires will lose the grip due to the large deceleration. Or the student can write this answer, a large deceleration means a sudden large force is applied on the brakes. It may cause injuries to the driver or the passengers in the car.